Hi dear students of plus 2 medical, non-medical and respected teachers. So in this video I am going to discuss Rydberg formula of spectrum of hydrogen like atom. So first of all, what is the origin of spectral lines? How spectral lines are produced? So we have derived expression for Rydberg formula, that is for wavelength and hence wave number. Now H atom at room temperature is in the ground state normally, but when H atom or any other atom gains some energy due to collisions of electrons or due to heat, rise of temperature, then it has sufficient energy to jump an electron from lower energy state to higher energy state. And atom is said to be in the excited state. So when atom is in the excited state, then it may come to the minimum energy state or ground state when electron jumps from the excited state to the lower energy state. And when electron jumps from any higher energy state to lower energy state, say from E2 to E1, a photon is emitted. And the frequency of photon or energy of photon is given by Bohr's frequency condition, which is given by h nu is equal to E2 minus E1. Now, according to Bohr's theory, total energy of electron in an orbit having principal quantum number n is given by E is equal to minus 2 pi square m k square z square E4 n square h square, where m is mass of electron, k is equal to 1.4 pi epsilon naught in SI system, z is equal to atomic number, E charge upon electron, n the principal quantum number, and h is the Planck's constant. And this negative sign indicates that energy is negative. So this is the mini energy state when it is in the ground state, or you can say electron is bound to the nucleus because total energy of electron is in an orbit is negative. So using this equation, so h nu is equal to, for E2 put n is equal to n2 square, and for E1 put n is equal to n1 square. So it will be minus 2 pi square m k square z square E4 upon n2 square h square minus plus 2 pi square m k square z square E4 upon n1 square h square. Or left hand side can be written as h nu is equal to hc by lambda. 2 pi square m k square z square e power 4 upon s square can be taken as common. It will be 1 upon n1 square minus 1 upon n2 square. Or 1 by lambda is equal to 2 pi square m k square z square is 4 over c h cube 1 upon n1 square minus 1 upon n2 square. And this whole constant except z square, that is 2 pi square m k square e4 upon ch cube is equal to r, constant of proportionality, and this is r is known as Rydberg constant, and its value is calculated by using the value of all these quantities. So r comes out to 1.097 into 10 to the 7 meter inverse, what is 1 by lambda, units of 1 by lambda. So this is the value of r, Rydberg constant. So nu bar is equal to 1 by lambda is known as wave number. Wave number means it gives number of waves completed per unit length. So the photon is emitted, how many waves are completed in unit length, so is known as wave number. So expression for wave number comes out to be this, and for H atom use z is equal to 1. So nu bar comes out to be r 1 upon n1 square minus 1 upon n2 square, which is required Rydberg formula for hydrogen atom. So nu bar is equal to, or 1 by lambda is equal to r 1 upon n1 square minus 1 upon n2 square, where n1 is the principal quantum number of the first stage, n2 is the principal quantum number of the second stage, and r is Rydberg constant. So from this Rydberg formula, Bohr explained the various series of hydrogen atom known as spectral series. Number 1, Lyman series. So when electron jumps from any higher orbit any high energy state to the ground state, that is for n is equal to 1. Then a group of spectral lines so produced is known as Lyman series. So Lyman series, n1 is equal to 1 and n2 may be 2, 3, 4, 5 and so on. Electron may jump from any higher energy state. So therefore nu bar will be equal to r 1 upon 1 square n1 square minus 1 upon k square, where k is taken as 2, 3, 4 and so on. So this gives wavelength and hence wave number for Lyman series. And from this, if we calculate a wave number or wavelength of Lyman series, so you will find this series, Lyman series, lie in the ultraviolet region. Ultraviolet region. Number 2, Balmer series. When electron jumps from any higher orbit to principal quantum number orbit having principal quantum number n is equal to 2. So n2 will be 3, 4, 5 and so on. So nu bar is equal to 1 by lambda will be r 1 by 2 square minus 1 upon k square k 3, 4, 5 and so on. So in this case lowest value of k is 3. So this set of spectral lines lies in the visible region. So Balmer series or Balmer spectral lines lie in the region of visible region. Then Paschen series, when n1 is equal to 3, n2 4, 5, 6 and so on. So this lies in the region of infrared region of spectrum. So this frequency or wavelength lies in the infrared region. So Paschen series lie in the infrared region, Balmer series lie in the visible region, and Diamond series lie in the ultraviolet region of spectrum. Then bracket series, for bracket series n1 equal to 4, n2 5, 6, 7. For profound series n1 5, n2 6, 7, 4 and so on. So these two series also lie in the infrared region, or maybe in the far infrared region. So this is all about the various series of hydrogen atom, which can be shown in the diagram like this. Suppose this is our nucleus, this first orbit, second orbit and so on. And 1, 2, 3, 4, 5, 6, 7 and no, when electron jumps from any higher orbit to n1, n is equal to 1 like this. So this group of spectral lines is known as Lyman series. When electron jumps from any higher orbit to n is equal to 2. So this group is known as Balmer series. Similarly, this is Paschen series and this is bracket series and this is profound series. So all these series can be shown very in a simple way on the diagram as shown in figure. So this is all about Rydberg formula for hydrogen atom. So go through it. In the next video, I will discuss limitations of Bohr model of atom and ionization energy and energy level diagram of hydrogen atom. Till then, stay tuned, be happy, all the best, good luck.